Okay, so first of all, this question that we're going to be dealing with today is dealing with conservation of momentum. And one of the biggest things for this conservation of momentum is this whole fact of initial of momentum, of course, adding them all up, is going to equal to the final momentum. In this case, it's very hard to get rid of the masses, especially when they're different in quantity. So we don't get rid of any masses in this case. Second thing, let's take a look here. We have 8 kilograms mass. So what we're going to have is this whole fact of collides elastically with a 5 kilogram mass that is at rest. Here's the important bit, rest, because this is going to be dealing with our initial. So 8 kilogram mass was traveling at the right at 4.5 meters per second. Right is another essential that we need to understand because of the fact that it's a direction. Momentum always has direction because of the velocity that deals with this. So after the collision is moving with a speed of 3.65 meters per second and an angle of 27 degrees. So we will have to use the components of x and y to figure out our direction, of course. So I love to always first start off with using this whole fact of understanding the given quantities. So here's what it looks like. I drew it out. It helps to always draw out every problem so we understand. M1 is going to hit M2. M1 is moving, M2 is not. Keep that in mind. So when they do hit, because of M1, it's at 27 degrees, we already know the angle that lives in here. I've given a coordination of positive dB, right, left is going to be negative. So let's look up under my given. Under my given, you're going to be finding that M1, 8.0 kilograms, that makes sense. M2, 5.0 kilograms. V1 initial is 4.5 meters per second, but I put the plus sign, just indicating that it is in the right direction. You need to include that. And then the other initial, just for the little eyes. Now we need to find 3.65, the velocity, that's final. So to do that, we have to use cos and sine. You could do this actually later on, but I like to do it at first. It's totally up to you. So I get a 3.25 dot dot dot, meaning that the number goes on. 1.657 dot dot dot, meaning the number goes on when you multiply it. Keep in mind, x always associates with cos, y always associates with sine. Those are our givens. Now let's look at required. Well, the question was asking for the actual mass, so that makes sense that we have the mass, now we have to look for the velocity. So V2F question mark. Now, with that in place, we have to understand that we have to keep moving on here and look at the analysis. So the calculations, how to do this actual problem. So to do that, we're going to actually first, let's get some facts out. Since mass 2 is stationary, the momentum initially is 0. So keep that in mind when we do the conservation of momentum, that's going to be 0, the initial of mass 2. Since mass 1 went in an angle direction, we need to find the x and y components of mass 1, which I indicated earlier. So this means mass 2 also has an x and y component, which we'll have to figure out right after. So the first thing that I recommend is use the two sets of equations to solve for x and y. So in the x direction, we're going to first figure that out. And we're finding V2, because that's what we asked, the problem, and the required. So this means the sum of momentum initial equals the sum of momentum final. And to do that, you will realize right off the bat, I got rid of momentum of x initial, of 2, of course, because it was stationary. So just say goodbye to it. That's the easiest way to look at that. Second thing now, we're going to be realizing that we have to also understand that all these other values are there, but we could even go to the next step because momentum equals to mass times velocity. We will have to actually show momentum equals mass times velocity. So m1 times v1 x, x means it's the coordinate of x, n times the initial. So keep in mind, m times v1. These are just the two values. Over here, here's the important bit. This one right here, we're using the value we got earlier for cos. And this one, we still are trying to figure out, v2. So with that in place, we move on, and then I am rearranging my equations right now. To rearrange equations, you have to subtract, well, subtract the m1 v1 of the x of f, and I move it to the other side. Well, I just realized that this should say m2. Okay, velocity 2, velocity 2. And this is velocity 2. There we go. Okay, so now we also have to get rid of the m's because that's how we solve equations. And then we're left over with the following big one right here. Okay, with that in place, what do we have next? Well, 8, we're substituting values, mass 1. V1 is the second value. Keep in mind there is no x and y coordinates for this because of the fact of it's just going in one direction. So it's a 2D, I guess you could think of. Over here now, we have 8.0 kilograms times 3.252173. Where did I get that value? The cos of 27. And that's one of the things that you could have done right now if you wanted to. It would actually be more of an accurate answer, but in the end, it still rounds up nicely. Divide by 5, you get 1.996523 ... really meters per second. Same goes for the y coordinate. Just change your variables now. But now keep in mind, because the y is going up and down, the mass did not start off going up and down. It started off going in an x direction or horizontal. So in this case, everything is 0 here. So if that's 0, we're only left off with the second part. Okay, so there should be 2 actually. 2 final. Okay, so in the end, using rearrangements of the equations again, and you're going to be realizing what ends up happening is this was 0 on this side, so you have to move it to the other end. You have to subtract it. Subtract this cancels out. So what are we left over now on the left? We have the subtraction of the m1 v1 fy over m2. The m2 is just representing the whole fact of its mass 2. Okay, so this crosses out, and we're left off with the final value. Multiply it. Keep in mind, where did I get this fy? Fy is basically my sine of 27 that I said earlier. So multiply them and everything, you get the final v2f that is in the y direction, negative 2.6512. Now find the resultant by using Pythagoras. So we have to take those two values that we found for velocity and actually square them, add it, square it again, and you get the following. So take the square root now, and you get 3.3180. And 2 sig digs, so 3.3. So this is why it's important to keep all the values in your calculator, but if you didn't, you still will end off with very close to 3.3, or you get 3.3 because it's 2 significant digits. Now find the angle. To do the angle, because we had a right angle triangle, we have to do opposite over adjacent using tan. So with that, we're going to find that angle that we are looking for, which is opposite over adjacent, which is the y over the x. Okay, so negative 2.65, what you got earlier, 1.996523. Should be best to use the whole value. You will realize you get negative 53.0190, 2 sig digs, negative 53 degrees. Now we put it all sum up into a paraphrase to help us understand what we just did. The final velocity of mass 2 is 3.3 meters per second, and it's at a degree of negative 53 degrees. Some people don't like to see negative 53 degrees, so they actually take one more step, actually put it in a 360 graph, and subtract it by 53, you get 307. I'm okay with either or. Hopefully that helps. Have a great day.